So now we're moving on to page 3, and we're continuing our work. If you look at problem 5, I don't see any plus or minus signs here. Nothing is breaking up the numerator and the denominator, so that means both of these are monomials. Remember, when you have monomials, you do not need to factor. All we're going to do is cross off matchers on the top and the bottom on the numerator and denominator. Before we do that, I'm going to add an invisible 1 for our exponent there. So let's just start on the left. We'll look at our coefficients. -4 over 6. Well, we know we can divide both of those by a 2, so this becomes -2 over 3. Then if we look at the x's here, we have an x squared and then an x to the 3. Remember, you're going to subtract your exponents. So 3 minus 2 is 1, and then we put our bigger exponent, or we put our answer where the bigger exponent is. So an x to the 1 goes on the bottom. And then we look at our y's. Y to the 5 over y to the 1. 5 minus 1 is 4. I'm going to put my answer in the numerator because that's where the bigger exponent lays. So our answer, this is a little messy, is -2y to the 4 all over 3x. Same thing as I wrote above. It's a little early in the morning, so my hands are quite awake. So now moving on to problem number 6, there's a binomial in the numerator and a trinomial in the denominator, so we have to factor. If you look up on the top, if I take out a GCF, I'm going to have 5r squared minus 4. Now, because I'm just doing this on a video, I'm going to erase this in a second. Streamline this a little bit. That's a difference of perfect squares. So if I have this 5r squared minus 4, and I do difference of perfect squares here, remember that's the one with the square root, r squared, the square root of r squared is r, the square root of 4 is 2. So I'm going to rewrite this. Oops. Get one that you can actually see. 5r minus 2, r plus 2. And then in our denominator, this guy right here, that's a trinomial. So we're going to do our 2 parentheses. And this time we'll start with r's. So we need 2 numbers that multiply to -12, add up to -4. So that would be a -6 and a +2. Now we're just going to cross off our matchers on the top and the bottom. And we're left with 5 times r minus 2 over r minus 6. So what we've done is we've crossed off the factors that match in the numerator and denominator, but this answer isn't quite simplified yet because we can still do our order of operations on this. I'm just going to distribute 5r minus 10 over r minus 6. That is our final answer. So for number 7, let me see. It's not letting me move up. On the top, I have 9 minus x squared. It's a binomial and it's perfect squares. So this is 3 minus x and 3 plus x. I just did dots on that. Now here in the denominator, it's a trinomial, but the a term is a 5. There's no GCF, so I have to do the AC method, the grouping method, however you want to call that. So I have to find 2 numbers that multiply to -15 and add to -14. So let's see. That would be minus 15x plus 1x. And now I'm going to bring down, if I can fit it, my first term and my last term. Group it. So I have 5x and then x minus 3 in the first group. And I'm just going to bring out a 1 for the GCF. And I have x minus 3. So this thing right here, I'm going to move up to the denominator. Wait a second. Sorry. Doing this before school. I don't think my brain is awake yet. 5x plus 1 over x minus 3. There we go. So what I'd like to look at right now that I want to cross off is the x minus 3 and the 3 minus x. Well, we know they're kind of the same, but their signs are opposite. They're negated. So I can still cross this out, but because the signs are opposite, I have to put a -1 in its place. So now this becomes, and you can put the negative wherever you want. I usually stick with the numerator. And you could say 3 plus x. I'm just going to say x plus 3 over 5x plus 1. So now remember, we can still distribute that negative to make this fully simplified. And you can do this in the numerator or the denominator. It doesn't matter. So I'm going to just distribute in the numerator, not both, one or the other. And here's my final answer. Now I'm going to pause this. See if you can do problem 8 on your own. The top is a grouping, the bottom is difference of perfect squares. So now for number 8, this top one is grouping. You're going to take the GCF of the first two terms, take the GCF of the last two terms. I'm just going to do this off to the side. So I have x squared and then x plus 2. And then in the second group, I'm going to take out a 3 and I have x plus 2. So when this is factored, it becomes x squared plus 3 times x plus 2. Okay, and then in the denominator, that's difference of perfect squares, x plus 2 times x minus 2. And now we're going to cross off the matches. And your final answer is x squared plus 3 over x minus 2. And remember, we cannot simplify these two x's because they're cemented in the numerator and the denominator. That it's a factor on top and a factor on the bottom. Let's move down. We have 2 more problems here, if it'll let me scroll over. I just have to find them. Oh, there they are. All right. Well, this looks definitely scary, but remember, we're just doing the same thing we've done. On the top, there's 4 terms, so I'm going to do grouping again. So I'm going to take out an A, and I have C plus B. And then I think I'm going to take out a -b in the second group, so I end up with C plus B. So factored, this is A minus B times C plus B, or B plus C, that doesn't matter. Just to make this a little bit neater, I'm going to erase this part. It's running into my problem. And then this right here, a little bit tricky. This is actually a trinomial. So we have an A, because that's what we start with. Instead of x squared, we have a squared. And now here, we're going to make this a -b. Because what happens when you do double distribution, originally, if you're going to simplify this, you have a squared minus ab plus b squared. And when you combine like terms, you get that. So let me get rid of this. Let's neaten this up a little bit. So this right here, I'm going to move over. A minus b times a minus b. Now I'm doing a lot of erasing here just to keep things a little bit neater, to hopefully make things a little bit easier, but you shouldn't erase your work. So now I cross off the a minus b's, and I am left with, I got to change this to alphabetical order, b plus c over a minus b, or c plus b. Remember, addition is commutative. All right, the last problem. On top, it's a difference of perfect squares. So we have 3x plus y and 3x minus y. Another wild one. That's a trinomial. There's no GCFs. So for this one, and it's tricky because there are also two variables. So I'm just going to write this down and then show you how it works. We have 3x, and then here I'm going to put plus y. And the reason why this works, when I do my double distribution, I have 9x squared, and then you have 3xy, and then here we have 3xy, and then y squared. And when you combine like terms, you get that middle guy. So I'm going to write this 3x plus y over, or times 3x plus y. And then these cancel out, and you're left with 3x minus y all over 3x plus y. These don't match. The y's are opposite signs, but the 3x's are not, so they're not equivalent. You can't cross them out.